All right, we're moving on into section 5, and I'm chunking it into a couple of different parts here. So call this 1-5A for squares and square roots. And here's today's learning objective. All right, I can evaluate expressions containing square roots. Okay, I know you've seen square roots before, but we need to revisit them. And then, of course, as always, dive in a little deeper. So here we go. I need you to draw a picture of a square. And if you have one there, then make sure you add this in here. The area of this square is 36, okay? All right. Now, I'm talking area, not perimeter. So I don't want you thinking about how do I find the length of each side? I just divide by 4. No, because that's not how we do it. Remember how you calculated area? You had to take the length times the width. What times what? Now, if it were just any rectangle, you could have a lot of combinations that work, like 1 and 36, and 2 and 18, and 3 and 12, 4 and 9, and so on. But this is a square, which means I usually don't call it length and width. I usually just use side and side because they're the same length. They're congruent. So what is the side length? Well, the side length is going to be what we call the square root. There's only one combo that works here, and that is what number times itself gives you 36. This is called the square root. Okay, now this particular thing is, I've got a whole bunch of information on here that I'll reveal now. So it's the inverse function or the inverse operation of squaring a number. Squaring means you multiply a number times itself. The square root is going backwards. You're saying, what number is it times itself that gives you that value? So we use this radical sign, it's called, in order to kind of denote this operation. So stop for a second and let's think about this, okay? So the square root symbol is a symbol that means a math operation, just like multiplying, dividing, adding, and subtracting. This means do some math, but specifically it means what number times itself gives you whatever items under this radical symbol. So when you read it, if I give you something like the square root of 9, I'm asking you to tell me what number times itself gives you 9. So in other words, like if it was a square, the square starts out with an area of 9. What are the lengths of each side? And you'd have to start thinking to yourself, what times what gives me 9? Oh, well, it's 3. Okay, 3 times 3 gives me 9. So the square root of 9 is 3. Okay, let's take a look at something here. Because if I asked you now, what's the square root of 25? Think about that. What number times itself gives you 25? Oh, it's 5. You're absolutely right. Guess what? There's another one. There's another number that when you multiply it times itself, you get 25. Can you think of it? Nope, it's not 12 and a half. Nope, it's not 10 or anything like that. Do you know what it is? You're going to whack yourself on the head and go, duh. It's -5. Ha ha. Because think about it. -5 times -5. Yes, that gives me positive 25. So therefore, whenever I ask you for the square root of something, so if I said, hey, what's the square root of 49? Technically, you can give me 2 answers, 7 and -7. Lazy mathematicians do this. They write plus or minus 7 because that means positive 7 or -7. Isn't that so lazy? Yeah. However, I am going to tell you that even though every single positive number has 2 square roots, the positive one, which we call the principal square root, there's also a negative square root. Most of the time when I ask you for it, I just want the positive one. However, read your directions carefully so that you understand what the book is asking you. So let's take a look at a few. Here I'm saying find the 2 square roots of each number. So when I give you 49 and I say I want the 2 square roots, you can write 7 and -7. Or if you're lazy, write plus or minus 7. How about 100, 10, and -10? It really is that simple, okay? Ooh, 225. You might not remember that one off the top of your head. Can tell you this, it's bigger than 10. You know what it is? Positive or -15. There you go. Okay, so you're getting the hang of this. If they ask for 2, give both the positive and -1. But most of the time, I just want the positive one. Now, it's going to be kind of important that because we use perfect squares a lot and it's important to recognize them for their stellar and unique and beautiful properties, I need you to memorize this list. The first ones, this first column should go like this. These should be automatic in your brain from your multiplication chart days. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Boom. These are perfect square numbers. Okay, so it's easy to go this way, but I really want you to focus on this side to know that, oh, 64, special number, it's 8 times 8. Okay, let's keep building. I really want you to memorize all the way up to 20 and to be able to rattle these off just automatically, just boom, 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 boom. 11 squared is 121. 12 squared is 144. 13 squared, 169. And here's a cool thing. 14 squared, the next one, just invert the last 2 digits, 196. We just did 15 squared, 225. 16 squared is still in the 200s. I can tell you this, 16 times 16, the last digit is going to be, let's see, 6 times 6 is 36, so it ends in a 6, and it just happens to be 256. 17 squared is still in the 200s. 7 times 7 ends in a 9, and you should get 289 for 17 squared. 18 squared, this pushes us into the 300s. 8 times 8 ends in a 4. So it's 300 something 4, and it happens to be 24. 19 squared. This one I always have to stop and think about. I know it ends in a 1, and it ends up being 361. Finally, last but not least, 20 is 400. Okay, if you wanted to go to 21 and 22 and so on, you can. But the big one, and I'm going to check these very shortly, next day or so, just drill you on these first 20 perfect squares. Okay, so those ones I want you to get familiar with, because now as we start applying this, we're going to be thinking about things that are square in shape and figuring out working backwards. It says, here's a square-shaped kitchen table. The top happens to have an area of 16 square feet. Okay, now hold on. They told you it was a square. So can you tell me the length of each side? Yeah, it's 4. It's a 4 by 4 thing, okay? Now, the top, will it fit through the van door that has a 5-foot wide opening? Okay, so think about it. If this side door opens up 5 feet, my table itself has a side of 4. Yep, I got a foot to spare. Yes, it will. Okay, the table measures 4 feet. 4 feet by 4 feet. So it'll work. Let's look at another one. You'll see some like this, where I just give you the radical sign. Now, before the directions explicitly said find both square roots. Here, if you just see it like this, I mean, I just want the principal square root, which means the positive one. Okay? So when you see the square root of 4, you may simply just write 2. This one, however, little tricky. See that stinking negative sign out front? I need you to think of this as the annoying little cousin that's getting dragged along to everything. It's a -1. The square root of 25 is plain old 5, but because of this extra -1 being multiplied in front, this time my answer is -5. Okay? Okay. What about fractions? Here's the deal. You can take the square root of fractions, absolutely. Let's say I gave you something like this, 16/81 as a fraction, and then I put the whole thing under the radical sign. So I'm saying, what's the square root of 81? What I'm asking you is what fraction times itself gives you 16/81. So look just at the numerator. What's the square root of 16? It's 4. What's the square root of 81? It's 9. So 4/9. That's the answer. What if I have something that doesn't work out really well, though? Like, what if I had something like 12/48 or something like that, and I wanted you to take the square root of that? Because then you're thinking, well, it's 12. Geez, that's not a perfect square. That's kind of hard to do. It's between 3 and 4, but I don't know, what it's going to look like. Same thing with 48. 48 isn't a perfect square. It's really close to 49. That's a perfect square. So this is really like probably 6.99 something, because it should be really close to 7, but that's not okay. So let me show you here. Notice, hey, 12/48, that's not in simplest form. Let's simplify this fraction first. 12/48 is the same as, it's the same as 1/4. Well, there you go. I can do that. Goodness sakes. The square root of 1/4, the square root of 1 is 1. The square root of 4 is 2. Now I'm cooking with gas. Okay? So here we're dipping our toes into some squares and square roots. What I want you to do is model along with me. Grab your workbook, okay? So find your homework and practice workbook, and I want you to turn to page 5, and let's go through and work these through together, okay? And I'm going to focus just on the top section, and I'll explain why in a little bit. There's a lot in this section. I don't want to get into classifying yet. When it says find each square root, you literally, just have to find the principal root, or the positive one. So this would just be 12. 196 is 14. Negative signs in front, so it'll be in your answer. Negative signs in front, it'll be in your answer. Fraction, square root of 1 is 1, square root of 49 is 7. Negative sign out front and a fraction. 4 and 25 are both perfect squares. I get 2/5. Okay, a contractor needs to cut a piece of glass to fit a square window. The area is 12. Okay? Find a length of the side of the window to the nearest 1/10 of a foot. Well, I'm not going to be able to do that. I'm just going to say approximately, how long would this side be if this is 12 square feet? Okay? Well, let's see here. I basically need a number that's around the square root of 12. 12 is not a perfect square. Let me show you something here. The square root of 9 would be exactly 3. Actually, let me write that the other way around. I had to get my eraser out, because I always like to have the actual number on the bottom, and then I'll put that square root estimate on top. So here's our number line. Zeros down here, 1, 2. So here's 3. 3 is the same as the square root of 9. 4 is the same as the square root of 16. Now 12, where's 12? Is it closer to 16 or closer to 9? Because it's somewhere in between these two. It's 4 away there, 3 away there, so it's a little less than halfway, is my guess. I would say this is approximately 3.4 to 3.5 square feet. Or no, side length, just feet. Whew, that was a close one. That was a close one. Okay. There you go. Let's look at this last one. Same sort of thing. It's a piece of cloth and it needs to fit a perfect square table. The area is 27 square feet. Okay, and I'm going to just say, let's estimate this a little bit. Okay. I know that to work backwards, I'm asking you what number times itself gives you 27. It's not a perfect square. I got to think of my, oh, that's a horrible number line. Good gravy. Good gravy. All right, so I need to think where the square root of 27 would fall. Okay, so I am just horrible today. I'm apologizing. 1, 2, 3, 4. Okay, so here's 5, and 5 is the same as the square root of 25. Here's 6, which is the same as the square root of 36. The square root of 27 is in between here, and the big question is, what is it closer to? Oh, goodness, this is really close here. So if I had to estimate, I'd say it's probably about 5.1 or 5.2 feet on each side, okay, because it's somewhere in between the 5 and the 6, but way, way closer to the 5. Whew. How you doing? Hanging in there? I'm having you stop because we're not going to talk about classifying real numbers now. We're going to wait and kind of save that for the next part of the lesson, okay? All right, so here's what I want you to do. Your assignment is to look into Schoology. There'll be some book pages and problems to work on from there. So go ahead, get started, and as always, may the force be with you.